Is that once we take the Delaware Aqueduct out of pressure, the water starts to seep back in through the leaks, and that's called infiltration, and that is the problem. So this is not a picture of the Delaware Aqueduct, but when I did a Google image search to try to be able to explain what the problem is, this is what comes up. So imagine that this is the Delaware Aqueduct and we were able to drain it. This is kind of what it would look like. So I try to, I've explained it like having like a perforated pipe, like think of like a perforation from like PVC pipe as like the leaks. And if I had a hose and I was spraying the hose full bore, the water would come out of those cracks. But when I would stop and turn the hose off, the water would start to come back in. So think of that as like pressurized, unpressurized, sort of. We just have this at a much larger scale. So this is the problem that we had, is that the water that was coming back into the aqueduct was coming back in at a much higher rate than we were anticipating. Now, the original math that was done based off of the numbers back from the 1950s, plus additional factors, knowing that the leaks were greater than they were probably back at that time. So this is what we saw. So this red line here was the actual rate. The blue line here is what we anticipated. So you can see that it started, this curve starts earlier than we anticipated, and it's a lot steeper than we anticipated. So the tunnel itself refilled, we were expecting anywhere about 20 million gallons the leak to come back in. It's closer to 30 is what we expected. The problem with that, though, is that the pumping system that we had in place is not big enough to handle the amount of water that we are now seeing in the tunnel. So we need to put new pumps or more pumps into the shaft 6 building there to be able to draw all the water out. Because could you imagine being 600 feet below sea level and drilling into the existing Delaware Aqueduct with water behind it? It's just going to come right at you. That is beyond unsafe. We cannot put workers into that condition. So this is why the aqueduct shutdown got moved to next year. So now we have math. We have new math. And we're going to redo that math one more time.
The new math didn't work too well.
Well, the new math is based on actual data from drawing it down. So we want to make sure that all of this work is going to be correct when we go in and redo it. So we're going to put in new pumps at shaft 6, but the new pumps also require additional power. So the power needs to be upgraded at shaft 6 because we weren't anticipating running these pumps throughout the entire shutdown. We thought we would just be able to dewater, turn the pumps off, and leave them off. Now they need to be available during the entire shutdown, which is gonna require more power. And we need to have the appropriate amount of backup power, in the event that there's like, some sort of electrical outage. We need to be able to have proper generation to run these pumps. So we're gonna do this again. So on October 16th, which, is a Monday, we are going to shut down the Delaware Aqueduct. And we're gonna do this dewatering exercise again. So the plan is that we're gonna go more than -90 this time. We're not gonna go any further than 350 feet below sea level, so we're gonna take it about halfway. So we're gonna drop it in stages. So we'll dewater it to -90, let it hold for like a day, see what it comes, see what the refill is, pump it down even more, hold it at a further depth, just to make sure that the farther we go down, we don't see higher rates come back in. And we're gonna do this in stages and hold it in stages so that we can make sure that our math is correct, so that we have the right pumping, we have the right electrical feed going into shaft 6, because we really only have one more shot at this, to get it right before we go into the shutdown of next year. So we are going to do this. It'll take, because we're gonna hold it, we're gonna anticipate doing this for 3 weeks instead of 2 like we did in March, just so that we have a little bit more time to be able to hold at the different elevations to see what the infiltration rate is. So once this exercise is done, we will again do another engineering report with our consultants and make sure that everything that we have ordered is still enough. And then in January, we will be upgrading the shaft 6 facility so that we have all the pumping in, all the correct lines in, all of the electrical in, and then we will be testing it, well ahead of October of next year to make sure that everything's good. And these are just some pictures. So just for some scale, this is an actual Jeep that they drove through in 1957, the last time that it was dewatered. And that's really all I have for you. I'm happy to take questions. Yes.
Just quickly, how much water do you think you'll have to pump out?
So we're anticipating putting in new pumps for about 35 million gallons. But we want to, it was 20.
Right, okay.
So now we're looking at
And
35.
where are you pumping that water to? Hudson?
The Hudson.
How do you getting pumped out of the tunnel? Is there
Hmm?
different holes?
Well, there's the shafts that are there.
It's like 800 foot and 600 foot high shaft.
Yes. So this is shaft 6 over here on this side. So, and then we made a new shaft, as we were boring this. So each side got new shafts, but there were already existing shafts on each side of the river. So the shafts go all the way down, to the bottom. So the water will get pumped up and out to the facility. And then from these facilities, they drain out into the river.
Jennifer?
Yes.
Would you, give us a little better information on elevation versus depth? Because you're citing 90 feet below sea level, but the aqueduct is what, 900 feet below the surface?
Yes.
So where is, at 900 feet below the surface, where's sea level? In other words, I don't think on the schematic. In
No,
other words, it's confusing. Is the aqueduct at 90 feet below sea level? Is the elevation 90 feet below sea level?
So the aqueduct here, it's not a straight line across. It's underneath the surface already, so it's about
Yeah.
700
Yeah.
feet below the surface.
Yeah.
Which is,
which is close to sea level.
That's the
no,
hut.
it's well below.
It's-
Yes, this is the hut.
At where?
Roaston, this is Roaston, this is Wappingers.
Okay, so
Okay.
it's very close to sea level, because the
Yes,
difference
so
between
it's
New York
very-
City and Albany is not great.
Right, so it's very close to sea level, but the tunnel itself is
Pretty close.
700 feet. Like these shafts that go down, they go 700 feet down.
So when you dewater, are you dewatering all the way down the aqueduct or
Not for the exercise.
no?
For the actual shutdown in October
Right,
next year, we will have to completely empty it, so
Right.
it will be empty
Oh,
to that level. But when we're doing the exercise, we're not taking all of the water
Right.
out of the tunnel. So we will be pumping it out so that the tunnel hits a certain elevation below sea level.
so you're actually just dropping the water in the tubes going down,
Yes,
in the shaft going
in
down?
shaft.
Okay, so,
And the leak, is that water, is that like, just, like surface water? That's leaking in?
That's leaking in, it's groundwater, it depends on where the leak is coming from, so it's under the river at this point, so it's all groundwater, but because the river's there, that whole area underneath it, very wet.
So the two areas that you're gonna repair, the tunnel in Wappington and Warson.
Yeah.
Is that the only place that you have infiltration in that whole line from the Delaware?
There's very small leaks, potentially other places, I imagine, but these ones are significant.
They were floating in the backyard.
So, yeah, the one in Warson isn't nearly as big as the one here in Roasted. So that one can be dealt with just by grouting the areas. So when that segment of the tunnel is fully watered, they'll be able to get in from the shaft on that side by Warson and go down in it and get the area.
Jennifer, is there any possibility?
Is it- Isn't that the area where they had limestone? And they foregone the sleeve lining, and they just thought the limestone would hold, and apparently it's not.
So we knew the limestone was there, and there is in this part of, parts of the tunnel here, there's a steel interliner that was put in there because we knew that the limestone was there. The problem was is that we didn't put it in a long enough length. So the big leak here in Roaston, it's actually, it's by the, Central Hudson facility there, the big pink building that you can see from the river. That's where the biggest part of the leak is, and that's actually right where the steel interliner ends. So if we had gone perhaps a little bit further with the steel interliner when the Delaware Aqueduct was first built, we might not have had this issue. We may still have had it anyway, but the limestone in this area is what we are attributing those. Yeah.
Is there any chance of it collapsing once you dewater?
So it's a very small chance of it collapsing. That is one thing that we have heavily studied and have done lots of engineering analysis on. It's something that's in the back of everybody's minds as a risk. It's been a risk this whole time, but the chances of that happening are not great.
even in what we're saying, where you're just going into the existing funnel, it's, its integrity is good enough to work in it.
When the water is flowing, everything is good, and I see it behind, is that a 14-foot diameter tunnel?
Yes,
Is it generally, full, I mean, the whole thing full with water, or is it half full? one full?
depends on what the flow is that we're sending down.
And you've not had any collapses in any other sections so far, right?
No.
That's good, Sam. Thank you.
Is the October 16th date firm now? You are absolutely
Yes.
confirmed that's when.
That's when we are gonna start. So we will starting in the morning on the 16th, like really like midnight, start taking it down to a zero flow.
So that'll increase the flows out of the reservoirs into the river. Because water, I mean, when you do this, the water normally go down, it will have to go someplace, right?
Right, but this isn't, it's not like the one that's coming in October of next year where it's
Okay.
gonna be shut down for months.
Okay.
So we don't have to create that large void in the reservoir.
But next year, when you totally dewater it, then it will.
Yes, then we'll start to draw them down, but because this is a short time
Okay.
period through, we can operate normally to the FFMP. And if we creep above the CSSO, we have discharge mitigation releases that we can make to bring it back down.
So next year in June or something, you're gonna start
Yes,
releasing the water to lower it?
yep, so the reservoirs will fill as they normally would with the spring melt and runoff. The new water year starts on June 1st, so that's our target to start drawing it down. It's also the highest demand period. So it's that we will start drawing it down over the summer months. And the releases will be based on whatever the hydrologic conditions are at the time. Like this summer, it was dry, so we didn't have to make large releases. To draw it down.
70%, is that your goal again? 70%?
It'll probably, some of the reservoirs will be probably closer to 60%. But again, that really just depends on what Mother Nature throws at us and how we're able to handle that. But last summer, the start of the summer was dry, so when we were starting, what we were looking to see if we had started the drawdown, what would that have been like? And we wouldn't have had to make big releases to be able to draw them down. We could actually just manage it through diversion because it was so dry and there was nothing coming in.
So do we have any questions in the chat, Stephanie?
There was one, but it's about, yeah, right.
Yep.
So this is gonna be the first time that Catskill waters will meet Hudson River waters. Because the watersheds are separate. This is the only time in Earth's history that theoretically that would happen.
Well, we do mix Catskill and Delaware together,
Independent watershed.
and we do have shaft 4 where we can take Delaware Aqueduct water and put it in Catskill Aqueduct. So we have lots of flexibility to be able to move.
You're defying Mother
water.
Nature is my point.
Yeah. That's what a reservoir
You're fooling
does.
with Mother Nature.
Lindsay,
Are we gonna have all the no-go?
yes,
Calculations
I will
next.
come back, as we get ready to get closer to it, just like I did last year. I will come back and I will do that again.
Did I hear you say that, the reason that you had to postpone this because there was 20 million gallons a day coming in?
But that's what we were anticipating. But when we did the dewatering exercise, it's between 30 to 30.
What are you gonna do with that water now that you've excluded from the system? Try and put a valve up there and use some of it.
We can't do that when we blow it off.
Just kind of kidding. That's an awful lot of water though.
It is.
That's just sitting down. That's good.
Can fill your pond.
Yeah, a couple times.
Hey, Jen, so during this shorter shutdown this fall, are you gonna be using the phone system?
Yes.
Okay.
So we will be using,
Lots of water over there.
yeah.
Evan Storm. Evan had a question.
Yeah, I have a quick question. I typed it. I don't know if you guys can hear me.
Yeah, we can hear you.
Yeah, I just was curious, Jennifer, if you have any idea. I know this isn't really based upon the Aqueduct shutdown, but just this past week, for the past 4 days, the West Branch release was dropped to 166 CFS, and I was just curious if there was if you knew why that was.
October of every year is when we have this big seasonal shift in releases. So with the FFMP, if you look at the tables, they're done by storage zone and season. So there's blocks of dates. in the FFMP, and we hit different rates for different seasons. And October 1st is the big seasonal drop that we have every year. And that's based on the Joint Fisheries White Paper between New York State, DEC, and Pennsylvania Fish and Boat, where we go into spawning season. The goal is to not have these huge releases in the river anymore so that we are not disturbing riverbanks and eggs. That's my understanding. But that seasonal change was made on October 1st. And I believe there's another one coming up in a few weeks. So
All right.
they change throughout the year.
Yeah, okay. I guess I'm familiar with the drops on October 1st. It's just based on fish spawning. I mean, we literally have seen dried up riverbanks and riverbeds this whole entire week for how low it is. I mean, we're literally killing the spawning habitat for the trout at this very moment. So it's just concerning is all, so I don't know. It just didn't really fit into the goal of the FFMP, I guess, this year because we didn't have more flow coming in from tributaries. But every year is different, I guess.
Any other questions? Thanks very much.
We've run out of goodies to give you. You've got our kid, you've got our t-shirt, that's all we got.
My office is
Sorry.
very well decorated.
Yeah.
Have a good night.
Thank
Yeah,
you.
right.
Thank you.
Thanks.
Thank you.